we were discussing Cmos. Now in Cmos there is a term called sub-threshold slope. Okay, sub-threshold slope, and it is given as S is equal to N kVt by Q ln 10. Okay. So what is this slope? This slope gives you slope of Vg ID में जो प्लॉट है इसका बिफोर द थ्रेशोल्ड वैल्यू, बिफोर दिस वैल्यू, यहाँ पर जो स्लोप बन रहा है gives you that. Now you might see that there are few terms which are used here. For example, there is a term n. Is it important? ये वाला जो टर्म है, this term, this is called thermal voltage. Thermal voltage. That is the energy which is carried into heat. Energy that is carried by the electrons due to the heat. And kV is the Boltzmann constant. kV is equal to 1.3 into 10 to the power minus 23 joules per Kelvin. So if I would like to find out the thermal energy at 300 K, that is at room temperature, what will be my value of V thermal? कितना होगा? अच्छा, Q is the fundamental unit of charge. Q, this is 1.6 into 10 to the power minus 90 joules. That means if you divide it by Q, you are getting the value in electron volts. ठीक है, तो अगर हम इसको करें तो कितना होगा? kVt 1.3 into 10 to the power minus 23 K into टेम्परेचर कितना है? 300 हाँ, divided by 1.6 into 10 to the power minus 19 कितना आ रहा है? 0.0225. हाँ, तो इतना वोल्ट्स, ठीक है, इसका मतलब है दिस इज अप्रॉक्सीमेटली 25 millivolts मैं बोल सकता हूँ. This is 25 millivolts V thermal. तो इसमें ये वाला तो मिल गया V thermal 25 millivolts. हाँ, this is 25 millivolts. What is this N? N is important here. Now N is called is equal to 1 plus capacitance due to the depletion region divided by capacitance due to the oxide region. ठीक है, जो ऑक्साइड रीजन है और डिप्लीशन रीजन है, कैपेसिटर कैसा होता है? हाउ डज कैपेसिटर लुक लाइक? ऐसा एक मेटल प्लेट्स होता है यहाँ पे, है ना, और बीच में देयर इज अ डाइलेक्ट्रिक, मेटल प्लेट्स एंड डाइलेक्ट्रिक. तो जो तुम्हारा सिस्टम है, जो मॉसफेट सिस्टम, वहाँ पर भी तो कुछ इसी तरह से बनना है ना. एन प्लस यहाँ पर ऑक्साइड, सोर्स, ड्रेन. So this is almost like an capacitor because यहाँ पे हमारा ऑक्साइड फॉर्मेशन हुआ. This is an oxide formation. So it is like a capacitor. So this is a dielectric. So this is a metal grade, metal dielectric. So it gives a COX, capacitance due to the oxide layer. Right. Now what is this CDP? CDP word का मतलब है depletion. Depletion region. Right. Depletion का मतलब है a process by which the carrier charges, they are pushed away. They are pushed away. Pushed away, they will be pushed away by what? By the electric field from gate. इससे जो इलेक्ट्रिक फील्ड होगा, इलेक्ट्रिक फील्ड जनरेटेड हियर, it will push away the charges. ठीक है, और this pushing away of the charges will create a depletion zone for you. So W stands for the depletion rate. Okay. जैसे डायोड में याद है पी इंजेक्शन डायोड के बीच में ऐसे एक बनता है, उसी तरह से. एंड ऑल्सो यहाँ पे जो चार्जेस होंगे दे आर कॉल्ड स्पेस चार्ज. ठीक है, स्पेस चार्ज. So again there is separation of charges. So due to this depletion layer, depletion region बना W, इसके कारण this will also give rise to कैपेसिटेंस, इसको भी हम लोग बोलेंगे डिप्लेशन कैपेसिटेंस. Okay. Now, as we have learned from our previous classes, depletion zone जितना कम होगा, the better it is for the MOSFET. So now, if we go back to this equation again, so we want this depletion region to be not existing, or if at all it is existing, it is very less. ठीक है, हम लोग चाहते हैं कि my C depth is as small as possible, and my C oxide is as large as possible. Okay. Now, if that is the case, if n is equal to 1, there can be two conditions. If n is equal to 1, that is the ideal state. This is the ideal state. Means the MOSFET working perfectly. MOSFET working perfectly. Okay. But if it is more than 1, that means somehow my C depth has increased, has gone beyond capacitance due to the depletion region